Hello, everybody. I got the feedback from last class that this needs to be more entertaining. So you can't see it, but I'm wearing a very, very festive hat. Um, I hope that's entertaining enough for those who wanted it to be more entertaining. So we have a bicycle is moving at a speed of 5 meters per second. How much time does it take him to travel 15 meters? So we have our A situation. We're just gonna, I'm going to cover this up because, actually, here. So we'll have A, and then we'll have our B information here. Okay. So for our A information, we needed to have, let's see, where are some of these colors? Okay, here we go. For our A information, the problem tells us that the speed was 5 meters per second. So our velocity was 5 meters per second. Our change in position was 15 meters. So our displacement was 15 meters. And the time change, of course, was going to be 15 meters over something that equals 5, which is 3 seconds. Okay? Or we can also show that calculation here. So V is equal to delta X over delta T, which is 15 meters is the displacement. And we don't know what delta T is, but we do know that velocity is 5 meters per second. So when we do algebra, it's going to be delta T is equal to 15 meters divided by 5 meters per second, which comes out to be 3 seconds. Okay. Now for B, we have our velocity, our displacement, and our change in time. And it says that for B, that the time is 6 seconds, and we don't know what speed, but same distance. So that means that our distance stays the same, which is going to be 15 meters. Our change in time is going to be 6 seconds, and we don't know what the velocity is. So what we do know is from here to here, our change is only, it doesn't change, okay? Now, 3 seconds to 6 seconds, 3 seconds to 6 seconds, our change doubles. And when something doubles, we're multiplying it by 2. So to find out what our new velocity is, we can go back here. All right, so we do know that our, let's be a little bit more festive in our colors. There we go. Our displacement stays the same, so stays the same. And then our time doubled. So 1 over 2, to keep it mathematically correct, 1 over 2 means 1/2. Okay? And since this was the one that we were trying to find out, this is what's going to go here. This is what we're trying to find out. So our variable, the coefficient that comes with our variable is 1/2. The coefficient just comes across here, so it's the same coefficient that whatever we wrote here is going to be the same for here. Okay? The original value, so this is the A value of our velocity, which is 5 meters per second. Okay, so our new value is going to be 1.5 times 5 meters per second is 2.5 meters per second. And a sentence that is describing this change is keeping the same distance. So if, or let's see, sorry, let's not start with if this time. Let's start with for the bicycle to travel the same distance but double the time, the bicyclist will have to cut his speed or reduce his speed by half. Okay. I am absolutely open to anyone correcting my English grammar. So for the bicycle to travel the same distance, I'm looking for the same distance, but double the time, the bicyclist will have to cut his speed by half. All right.